Hello friends, welcome to Vvsm Academy. Today I would like to welcome you in this new year, starting academic year. Introduction to basic electronics. Keywords: conductors and insulators, conduction band, p-type, n-type, electrons, core, intrinsic. Well friends, in our physics classes we have studied about conductors and insulators. The basic principles of physics. What is conductivity? The property of conductors that allow them to conduct electricity is known as conductivity. Then what is electric current? The flow of electrons in a conductor is known as electric current. You know, my dear friends, this is a very important topic concerning with electronics. What is electrical conductor? The charges transferred to an electrical conductor distribute until the force of repulsion between the electrons in areas of excess electrons is decreased to the minimum value. Here are the very important 5 electrical conductors: silver, gold, copper, steel, seawater. And at the same time the insulators, which are also called as bad conductors: rubber, glass, oil, diamond, drywood, etc. My dear friends, now I would like to divert your attention towards the electronics. The keyword is transistor. What is transistor? Transistor is the symmetrical to a vacuum triode and relatively very small in size. It is a composition of two words, transfer and varistor. A transistor consists of 3 layers of semiconductor material, and each layer is having a capability of transferring current to other layers. For example, the germanium and silicon are the most preferable semiconductor materials which conducts electricity in semi-energetic way. By the process of doping to a semiconductor material, the result adds to the additional electrons to the material to produce holes in the material. The outer layers have widths much greater than the inserted p-type and n-type or n-type material that is typically in 10:1 ratio or less even. Lower doping level decreases the conductivity and increases the resistance of this material by limiting the number of free carriers. Well friends, semiconductors, the elemental semiconductors, for example, germanium, silicon, etc. In the periodic table, I would like to divert your attention toward the periodic table where you can come across the semiconductor, elemental semiconductors, particularly silicon, germanium, and other things, tellurium, etc. And the compound semiconductors, which are composed of 2 or more elements. Well, intrinsic semiconductors. The semiconductors are classified mainly into the intrinsic and the extrinsic. The intrinsic semiconductor is the purest form of semiconductor, elemental, without any impurities. Naturally available elements like silicon and germanium are the best examples of intrinsic semiconductors. Now let us discuss about the intrinsic semiconductors. 3-dimensional diamond like a crystal structure for carbon, silicon or germanium with a respective lattice spacing equal to 3.56 to 5.43 and 5.66 angstrom units. Schematic of two-dimensional representation of silicon and germanium also given in the figure. You can refer that. Silicon or germanium, covalent bonds and bonding electrons. Well, friends, as I told you, those intrinsic semiconductors start conducting temperatures above the room temperature, developing import electronic devices. Using these can pose a problem. This led to a need for improving the conductivity of intrinsic semiconductors. Let's find more and more about this. And the solution for that is an extrinsic semiconductors. After some experiments, the semiconductor, when a small amount of impurity was added to it, that is nothing but a doping. The process of doping, the impurities are dopants, which are called dopants in this process. An important condition to doping is that the amount of impurity added should not change the lattice structure of the semiconductor. To achieve this, the size of the dopant and the semiconductor's atom should be the same. Here are in the figure, if you divert your attention towards the figures, extrinsic semiconductors, donor impurity contributes free electrons, acceptor impurity creates a hole. That is called a hole, that is N-type and P-type. These are the very important concepts of. Now coming to the higher level of electronics, what is a Fermi level? The highest energy level that an electron can occupy at the absolute zero temperature is known as Fermi level. The Fermi level lies between the valence band and the conduction band because at absolute zero temperature the electrons are all in their lowest energy state. In physics, the concept of energy is strictly because it has a different meanings depending upon the context, what you impose or what you talk about. For example, in atoms and molecules, energy comes in different forms such as light energy, electrical energy, heat energy, etc. In quantum mechanics, it gets even trickier. In this branch of physics, scientists rely on concepts like Fermi energy, which refers to the energy of highest occupied quantum state in a system of fermions at absolute zero temperature. Then what is Fermi energy? Named after the physicist Enrico Fermi, Fermi level is the measure of the energy of the least tightly held electrons within a solid. It is important in determining the thermal and electrical properties of solids. It can be defined as, the Fermi energy is a concept in a quantum mechanics usually refers to energy differences between the highest and the lowest occupied single particle states, single particle states. In a quantum system of non-interacting fermions at absolute zero temperature, the value of Fermi level at absolute zero temperature is minus 273.15 degrees Celsius, is known as the Fermi energy. It is also the maximum kinetic energy an electron can attain at 0 kelvins. Fermi energy is constant for each solid. Thank you for listening. See you again in the next forthcoming classes.